Sawadee. And that's all I know in Thai. So I'll be delivering this speech in English, and I will try to also answer the question at the end. But if you feel like I'm going too quickly, or you feel like there's something that I'm missing during the presentation, feel free to raise a hand, and I will stop and we can go over it. Okay? So today I will talk about not 5, but 10 tips to secure our app. That's a lot, and we only have half an hour, so it will be blazing fast through some of them. But I'm sure you will remember everything I'll be telling you today. So, my name is Alex, and I'm really excited to be here at Firebase Summit Extended Bangkok. And I'm going to talk about some of the really cool stuff that you can do and how to do it properly. Okay, let's get started. So when you build your app, there's a lot of things you have to take care about and think. However, when you build with Firebase, you have less. So where do all of these go to? Where did these things disappear? Well, some of them, like Auth, language, updates, or security patches for your server, are handled by us. Some of them, like preventing DOS and abuse, are also handled by us through our infrastructure teams. And some of the stuff, like authentication, schema validation, or securing business logic, are provided by us, but you have to configure them. In this talk, I'm going to cover the best practices on how to configure these security aspects of your app. So, first tip, or actually tip number 0, don't trust your client. As you can see here, this is a very simple website that we're able to write one of our demo projects. You can see all my application configuration, the API keys, the database URL, storage buckets. Everything is visible and readable by anyone who downloads your website. And this is intentional. You shouldn't be afraid of it. These are just identifiers to direct traffic properly. If you follow our tips, you won't need to worry about these being exposed in public. Now, in spite of what I told you just now, you can actually trust Auth. You don't want to trust this. But along with that is also this. And you can totally trust this portion. So what I'm meaning here is the request portion of any web request from a client cannot be trusted by design because you saw everything is exposed. It's easily to craft any kind of request that would look valid from a Firebase standpoint. However, there is a small portion that you can use in your app, which is trusted because we do some checks for you, and we make sure the portion of the request that handles authentication is actually what it seems to be. And I will talk a little bit I'll go into more detail a little later on how we do this. So let's get back to our app. How does authentication work? Usually you would get some data from an auth provider, and you generally use it on the client. As far as the server is concerned, it is dirty. So in addition to this, we provide this. So it's so when you call the sign with credential on a client, what Firebase Auth does is it passes this access token here. But how do we know that this is a real person? Well, we verify it. So we pass back an user ID, and we pass by a GWT. So what is this? What is this GWT? It has a header, which is essentially your auth, your session ID, and then it has some data. And the data is all the information, all the context that your app needs in order to know who you're dealing with. And also we provide a signature. And the signature is a cryptographic piece of logic that ensures that the data here has not been tampered with. This way, we can make sure the little portion of the auth data is always secure without having to go through the hoops and loops of re-authenticating your user. So if anybody messes with this will be invalid. That's essentially how we can make sure we have a secure way to check if a user is who they belong. And this is very important because all of the other tips rely on this assumption being true. So let's go to the next few tips. Now the second to the fifth tip is all about security rules. So Firebase security rules is the stuff that allows your client to only do the things they're supposed to. Firebase rules provide a fine-grained, attribute-based access control system. So what does it mean? Let's assume you have a simple project with this kind of structure. You would have a data field, and you would have a flag marking a project either public or private. So more than an authorization, we can use the schema validation and the business logic validation to allow or deny access to a certain data object or to certain functionality in your app. So what do you need in order? So what's the first step in order to provide this functionality? Well, first you want to basically authorize access from your user to your data. If we boil this down to the simplest concept, you can have either public or private data. Public by definition means everyone can read anything. And of course, it's always a good idea to restrict rights to only people who are supposed to. Now, for the private projects, let's assume we only want members to read and write. So, in order to do this, we can use the concept of security rules. Now, this rule does exactly that. It allows read to everyone for a public project. Do we have a pointer? Yeah. And it allows write to the data owner or the project member. Now, for the write access, like I just said, it's always good to have some additional checks. It's always good to only allow writes to authenticated users. Even if your application uses anonymous users, you can use anonymous authentication method so that even the users who don't sign in still have an identity created for them. Now, what about this project member? Well, the project member is something we call a function here. In order for you to have a easier to read rule, you can group such functionality into functions. This way, you can have your business logic nicely done in a clear and concise way. Okay, so if you follow this link, and you can find the link in the presentation, I'll provide you at the end with a little bit of information on how to find this talk so that you can watch it later at your own pace. Well, in this link, you'll find more information on how this role-based access control works and the detailed example of this use case. I'll just skip to the tip number 3, validating your schema. Okay. So besides validating access to data, it's also very important to validate the data that is being written to your database. The reason is it's very easy, either by mistake or intentionally, to get an inconsistent or even invalid data format that can eventually break your application if you allow people to just write everything they want to the database, even if they're authorized, even if they're supposed to have access to that collection. That's why it's really important to validate the schema as well, not just the access. So in order to validate the schema, you can use, yet again, the rules, but it gets a little bit tendentious real quickly. So that's why I actually have a tip here for you. Try to use, why don't you use protobuf? We at Google use protobuf extensively to validate, to both validate the data we send to servers and also use it as an infrastructure technology to do some other lower level stuff. In case of Firebase, the protobuf library will be super useful for you to only have to write once the structure of your business logic, essentially the business model, and then have it generate project rules for you that will assure that the data in Firebase Firestore is in fact valid. And it will also generate or scaffolding code that you can copy paste or automatically integrate in your project so that you don't have to worry about your apps becoming obsolete as you update the schema. This way, you will only have to compile things to make sure the schema is still valid with your business logic, but you won't have to ever worry about having inconsistent changes across the broad range of your clients. And this will essentially become this. All your validation logic will be encapsulated in this function, and you'll only have to worry about some of the basic stuff that we talked a little earlier. Tip number 4. Implementing business logic checks. Okay, so what is business logic checks? It's essentially how do people update the data and how do you change a project from private to public and back. On the previous step, we talked about validating the actual data. Now we're talking about validating the workflow. This is a rather detailed thing to cover, so I'm gonna skip this. However, feel free to watch this video. In here, Mike McDonald talks on how to do this really nicely. The video is called How to Build a Secure App in Firebase, and it's included in the Firebase Pro series. You can also find it by following this link here. Okay, a few interesting gotchas to look for. First, rules are not filters. Rules validate data, validate queries, but not data. Let me give you an example. Okay, so let's assume we have this same structure we talked about before. And of course, some of the projects are public, some are private. Yeah. Let's go ahead and try to query for our public projects. Now, how should we do that? Well, we obviously want to have some kind of rule in place if we don't want to expose the private project to the world. Now, the problem is if we just query for all of the projects, there is no way to know if a project is private or not before we actually fetch it. That's why a query which we just ask for all projects will not work. It will return 0. It will say access denied, even if all your projects are public. Why does this happen? It's because Firebase uses the rules in order to guarantee that all the data that will be fetched will actually match this rule before fetching the actual data. The reason why this is rejected is because when you look up the data, there is no way to guarantee upfront that all the projects are actually public. If there is one private project and we fetch it, we would actually violate this rule. And in order for this to not happen, we'll just discard the entire request because there's no way we can guarantee all the project statuses are public if we just query for everything from our entire database. So what do we do here? It's really simple. We just have to make sure we add an extra condition. If we have the condition, we can guarantee that all the data fetched from here will be indeed public. So this rule will actually be true for all of the data that's fetched. And this way, the data will actually flow back and everything will work just fine. Okay, tip number 6. Custom authentication claims are useful. What does this mean? Okay, if you remember at the beginning of the presentation, we had that big chunk of data about the authenticated users that were also hashed in our checksum at the end. You can actually put your own stuff in there. And the reason to do that is because you can actually use this to have more advanced handling of your security rules. How do we do that? You'll do a call like this, which essentially will set a custom flag, a custom property in your Auth object for that particular user. Okay. So at some point in the future, your client is going to request a fresh ID token from the server. When it does, our server can send up this new GWT object with a new claim baked in. And when this happens, we can use this new data that you set there to make sure that the client is indeed allowed to do a specific operation. This way you can take care of these really complex security rules in your server-side code and then do a very simple lookup when you read the data without having to worry about writing complex validation functions. Now, should you do this for everything? Nope. And that's because there are a couple of restrictions. First of all, this object can only have a maximum of 1,000 bytes. And the reason is because we will be sending this object back and forth in the pipe on every request. So you don't want to have a big payload there. It will slow down your app and it will slow down our service. So that's why we have a limit of 1,000 bytes of this payload. Another issue is that in order for these values to work, you need to refresh with the token. You need to wait for the token refresh. Essentially, you need to wait until the server does a revalidation and recomputes the hash of the request. And that can take sometimes up to 1 hour. So obviously, you don't want to change the data in this object too often, because that might make your user not actually have access to the stuff they think they should have access to. So really, you should use this for some things. Essentially, the best use cases is, hey, this user is an admin. Should they have really broad and unrestricted access to most of the stuff? For this kind of stuff, you can use this. It will really help it will really simplify your code. But if the user joined the chat room, so now they have access to a bunch of extra messages, you should really not use this stuff. Instead, just use the rules, security rules, or cloud functions to do that kind of validation, and you'll be perfectly fine. Now, there is a great video about this topic, and Jen did an amazing thing, explaining this into much detail. If you think you could use this type of advanced authorization mechanics, and make sure to watch the videos. It's really great. Now, next tip. Test your rules. Well, it goes without saying that testing is good, especially when you test the code that can essentially prevent your user from reading their data and using your app altogether. So, you have a bunch of ways to test it. The fastest and simplest way is in the admin console. You essentially select the type of operation you want to test, you select the location, and you can provide some data. You can also provide some a payload, authentication payload. And once you run the simulation, it will essentially test the rule. And if the rule if your user is actually allowed to do that kind of operation, you'll have a green message like this, and it will highlight the rule that allowed the operation. If the operation was denied, because you either did not create any security rules at all, or there is not a single security rule that would allow that particular operation, you'll get this kind of message. And as you can see, there is none of the lines are highlighted. That means all of these rules were evaluated and none of them applied to your user and your data at the same time. Now you have another great way to emulate. You can emulate it locally. And this is a great way to add some unit tests and some integration tests to your app. You can test a security rule without having to connect to the internet by running this script locally and using our CLI tool to set it up. This way you can have the guarantee that the client will not break as you change your rules or schema in your database. And it also allows you to have a really nice continuous integration setup for your apps so that you can feel at ease whenever you do a hot patch or you publish a new release of your app, that nothing breaks and everything is still secure for your clients. Tip number 8, consider cloud functions. Cloud functions, in my opinion, cloud function is better than overly complex logic. And I'll try to explain why cloud function is better than complex rules. Let's assume this use case. You have a chess game. So when a player makes a move, we're going to want to update our game document with a bunch of stuff. But there's a few questions you have to answer before doing that update. Is this move legal? Was it this player's turn? Is the state of the game accurate? So let's assume you have this kind of payload, which includes a game state, which contains the entire board data. And in order to send this payload back, you have to do a lot of validation. And I don't really want to write all these validation rules, not for chess players. So what do you do? What can you do here to make sure the game is actually secure? You can, for instance, create a temporary collection, create a collection of pending moves in which you would add all these moves that were sent by the player, but not apply them immediately to the game state. Instead, you'll have a cloud function that will read the data from the pending moves, do all the validation required, and recompute the game state. So, if the game state looks like this, and the pending moves looks like that, all you have to do is just write your logic, extract the data you need, recompute everything, validate everything inside your cloud function, and then dump the result into the database. Because cloud functions run in the cloud, and their source code is controlled by you, it's a secure environment. You can trust the data that those cloud functions generate. So you don't have to do too much on the rule side. All you have to do is just restrict write access to this entire collection to no one, and only use the cloud function to ever update the game state. This also allows you to have a really complete game state that is easy for the client to process, and it's easy for you to maintain. Tip number 9, listen to warnings. Well, it goes without saying that if you create a new database and you decide that you really don't have time to set up rules while you write your prototype, so you allow random access to it to everyone, and you get some stuff done, and you know that one day before shipping it, you'll eventually secure a database. However, it's boring, and you have to work fast, and you have to ship it, and then suddenly you remember you didn't secure it. So this kind of sucks. That's why we introduce a bunch of things to remember you that whenever you have this exposure in your app, you're supposed to fix it before shipping the app. That's why we have added it into the admin console, and we also send these kind of emails. We'll be nagging you with these kind of emails until you secure your data. So please, if there's one thing I want you to take away from this entire talk is don't ignore these emails. This single thing could save you a lot of trouble in the future. Now, for the 10th tip, and this is an interesting one. Keep your employees on the short leash. Well, not literally. So, you know that I know that we're all worried about this bad guy. He can be an evil hacker, or a disgruntled employee, or a colleague with a weird sense of humor trying to mess up with our data. However, really, in real life, usually the problem is this. Let's say this is Joe's second day at work, and oh no, did he really delete all the data? Now, what can we do to prevent Joe from doing this? Before, if you needed to add a new person to your team, in order for them to be able to, for example, create an A/B test for your app, you'd have to give them editor access, which essentially means they will have right-ever access to your entire Firebase project. But now, you can have a more granular control of what you allow people to do. By using Firebase Rules, which is the recommended way of handling this kind of stuff when you have more than one person on your team, you can actually make sure your colleagues only have access to the portion of the project they really need to have access. This way, you can keep your project safe and keep them easygoing without having to worry that they'll mess up something in your production environment. So these were the 10 tips I wanted to tell you. I hope you remembered everything. But if you didn't, don't worry. You can rewatch this talk on YouTube. It's presented by Mike McDonald and Todd Keplerman. And you can easily find it by searching for this string on YouTube. Or just go to the YouTube channel, find the playlist that includes our talks from this year's Developer Summit. And if you browse through them, you'll see that this talk is somewhere in the middle of that playlist. Should you have any questions, feel free to ask them now, or you can find me later, and I'll be happy to address them. I will also have a second presentation about Cloud Firestore after the coffee break. Thank you, and see you later.